Okay, guys, so it doesn't look like I'm able to share my screen correctly for some reason this time. And so I'm just gonna work with like what I have right here. In fact, what I could actually do to make it my life a little bit more simpler is I'm going to just take off my HDMI cable. Okay. Okay, so some updates. Okay. Office hours, still the same time, Fridays, 5 to 6 p.m. on Zoom. It's the same link that you're on right now. If you have any questions to ask me. In terms of exams, this is the first recitation, at least for recitation 4, section 4, that we're having after the exam. So, I mean, how do you guys feel? I still got a grade, a couple more for question 6, but all in all, looks like, everyone did pretty in the ballpark. Let's read the chat. I feel like we'll see. We'll see. Actually, don't remember your score at all, but as long as you tried, you did your best. That score will reflect that. And if you didn't do as hot as you thought you would, we have other opportunities. You have the rest of the assignments, you have the other exams to boost your grade up. Okay. I don't know about a curve just yet. But certainly Ames is the person to ask if there will be a curve. But as of right now, there's still a couple of question 6 exams to finish. So like basically every question is done except question 6. That's all that's left in grading. So I'll hopefully try to finish that up in the next 2 days because there's so many different solutions that people use to answer that question. Question 6, by the way, if you don't recall, was the one with names and the scores, and you have to calculate the average of the midterm without the person that started with the letter C. Okay. Yeah, so I thought it would be a little bit more easier, honestly, personally, because it was in person, but it was honestly like the same format as the previous one. If anything, this exam was maybe a little bit more different, a little bit more easier in the sense that it gave you those first 2 problems where you had to find the values of like I and whatever. So that was the easier part from last year's or last semester's exams, but they're relatively on the par. The only difference is that you don't have access to the library on deck. Okay, so don't worry about it. We'll talk about it after the grades release, which I'll try my best to do by Wednesday. Okay, so I'll try my best to get it on Wednesday. Any questions related to like logistical stuff? Okay. 5 more seconds. Okay, so today I'm going to keep it a little bit more easier. Actually, we do have a question in the chat. Will there be a curve? I just said it's up to Ames. So the curve is up to Ames. I'll see what the average and like the means are, but we'll see from there. It's gonna be based on like everyone's final numerical grade, and then we'll see if there's a need for a curve after that. But that's not gonna be decided by me. That's gonna be by Ames. And then for Faiza, you said that, okay, so how we split up the grading was that each person got a specific part of the question to a specific part of the exam to grade. So Professor Ames, for example, he graded the first 2 questions on everybody. So all 200 people in the class, he graded all the question 1 and 2. So in the case for me, I graded everybody regardless of sections question 6. Okay. And if I think there will be regrading requests. There is a regrade request feature built into the thing that you will when you get back your exam, it's going to be virtual. So like you'll get back your exam on Canvas, and you could see what you got wrong and what you got right, and the justification why you got that grade. And if you feel like that grade does not adequately represent what you got, there will be a regrade request. At least for question 6, there will be a regrade request because I'm willing to accommodate and hear people out for question 6, but the other remaining questions will be on the basis of the other TAs, and question 1 and 2 is Professor Ames. Are we using Gradescope? Yes, we are. So you will get your exam on Gradescope. Okay. And that's where the grading as well. The rubric that we use, well, the rubric that we each made, it'll all be on there. Okay. Okay, so don't worry about that too much, but at the end of the day, you tried your hardest, and we'll go from there. Okay. So recitation 6, what I'm planning on doing is just making a very simple lesson today. It's going to be an introduction to pandas. I was supposed to do this actually during spring break and release a video for you guys, and then I just got lazy for some reason. And so we're just going to do introduction to pandas right now, rather than being a separate video on its own. So yeah, it's going to be very simple, just getting your hands wet in pandas and trying it for the first time if you haven't so already. Okay. And of course, my email is there if you have any questions. I'll try to respond to you in at least 2 to 3 days. And feel free to nudge me if I don't respond to your emails, if it's urgent. Okay. All right. So what is pandas? So just like NumPy and the other stuff that we've seen in this course, we use a lot of libraries. And so pandas is an example of a Python library, and it's specifically used for data manipulation and analysis. And it has easy to use data structures and data analysis tools, which separates it from other libraries. So when we use pandas, we're often using it in the sort of a data science perspective, or we're using it from a data science standpoint, because a lot of the stuff that pandas offers, if we didn't have pandas library, it'd be rather difficult to code. It could be tedious to code. And sometimes it's just like, it's just a lot of work. But pandas has a lot of libraries for us to use. Sorry, it has a lot of built-in features for us to use that make analysts. I can't say analysts. Yeah. Easier for us. Okay. It's built on top of NumPy. And so you guys know NumPy. NumPy, we used it in the context of NumPy arrays, and we did a lot of numerical computations with NumPy. So pandas use and extrapolates a lot from NumPy. Okay. And if you are applying to jobs, pandas is something that they use in data science and machine learning projects. Okay. So just a rough summary of the key features that pandas has to offer. One is the data frame. Data frame is what you're going to be using a lot of. You're often, when you get a CSV file or an Excel file, you're going to convert it into a data frame. Okay. So what is a data frame? A two-dimensional table-like data structures with rows and columns. Think of it as a 2D array. But it's not just a 2D array. It's like Python's version of an Excel sheet. And you have ways to, name the columns and name the rows and make it very easy to actually run data analytics. I'm going to use the data analytics because I don't know why I can't say analysis right now. Data analytics. Series is a little bit of a simple form of data frame. It's a one-dimensional array like data structure, and each of this will have like a position. So like the first one will be position 0, position 1, kind of like a one-dimensional array. So that's what a series is. Nothing too difficult. Okay. Now data cleaning, data manipulation, and data visualization. Those are the 3 steps that you guys are going to do when you do future assignments with NumPy and pandas, because these are the 3 basic steps that get you into data analyst. Now, when you are given data, you're not going to be given like the best Excel sheet or the best CSV file. It's going to have missing gaps. The data might not be accurate. There could be outliers too. So the first step is data cleaning, or you can often call it data pre-processing. And this is when you remove missing and null data, you rename the columns and filter the rows. So when you import a CSV file, for example, it's just going to be like a random 2D array. But like, what's the point of having a random 2D array if you can't really, or what's the point of having that if you could just use the regular version rather than using the pandas version? Well, pandas comes with the fact that you can name the rows, you can name the columns, and then you can use those names and columns to index the different elements of that 2-dimensional array. And that becomes very, very useful when we're extrapolating and analyzing large sums of data. Okay. Data manipulation is the second step. This is when you're going to be grouping, merging, joining, pivoting, reshaping. So you're going to be changing the data, to suit your needs, not like, alter the data altogether to like, that is a business on its own. But my point is that there is a step where you can like group the data, merge the data, maybe even subset the data, so that you want to look at specifically or tailor in on a specific subset of the data. And so data manipulation is the second part. And then data visualization. Data is, there's different rows, different columns of information. And, we don't really have time to look at each itty bitty detail. So what we want to do is generalize the data and see it in a pretty picture. And so we use different charts. We use like, scatter plots, maybe a mosaic plot or something like that of that nature, to sort of visualize the data and see, okay, what is going on here? What is the trend that's going on here? What percentage of this is that? So data visualization is very easy with pandas, and it's very useful as well. Okay. Now you're probably wondering, what's the difference between pandas and NumPy? Okay. So we have like a data frame in pandas. We also have a series in pandas. But in NumPy, we also have a NumPy array that could be one-dimensional or two-dimensional. And so what are the differences between them? So pandas and NumPy are both Python libraries used for data manipulation and now analysis, but there's some key features between them, okay? So data structures, NumPy provides multidimensional arrays, and pandas has the two main data structures, which I said were the series and the data frame, okay? So now in series is capable of holding any type of data type, and data frame can do the same as well. They can hold different types of data. But if you remember from a NumPy array, that may not necessarily be the case, okay? Functionality, NumPy is very good in mathematical operations. That's why we use it a lot. We use it we used it for calculations a lot, and changing the data, doing a lot of multiplication, addition, subtraction. If you remember from the exam, right? A lot of people use NumPy for question 6 to just do np.meet. And that's very powerful with that NumPy. That's a powerful feature that NumPy provides. It does these calculations very, very easily, rather than saying, okay, let's add up the sum, let's increment and count how many of these guys are here, and then find the average. Okay. And then speed is another thing. NumPy is going to be generally faster than pandas. Pandas, again, is built on top of NumPy. So, we have like more features with pandas, but at the same time, if you want to do quick manipulation, if you want to do quick calculations, rather, you would use only NumPy. But at the end of the day, at the grand scheme of things, it just, these things don't really matter. I mean, speed does matter. I'm not saying speed doesn't matter, but the differences between NumPy and pandas don't really matter, because you're just going to use them together most of the time. Okay, so just to sum it up, NumPy is for mainly going to be used in the context of numerical and scientific computations, and then pandas is going to be used for data manipulation analysis. Okay, so NumPy is not going to make you a graph. Pandas is going to make you a graph. NumPy can do calculations. Pandas can also do calculations, but you're most likely going to use NumPy. That's a good way to summarize it up. Okay, so pandas series, that's the first data structure that I mentioned. So think of series just exactly as you would think of it. It's just a one-dimensional labeled array in pandas, okay? So it can hold any type of data type. It could be numerical, categorical, or textual. And series has two main components. It has the index and it has the data. So here's an example code that I put that creates a pandas series and then actually prints it out. So we import pandas as PD. We did the same thing with NumPy. We just named it MP. Now we create the series with a default integer index. So we're not putting we're not altering the indexes to suit our needs just yet. We're just going to be using the default indexes that pandas provides. And the default indexes that pandas provide is very, very simple. Position 1, the first element is going to be position 0. The second element is going to be position 1. And the third element is going to be position 2. Okay. Stuff that you already know, okay? So we create a PD.series, and within that, we put in an array. An array has values from 10, 20, 30, 40, and 50. And this list will be converted into a pandas series. And then when we print out this pandas series, what do you guys notice? Well, we notice three things, actually. We notice the type, we notice the elements, and we notice the index. So the indexes are the first thing that you see here, 0, 1, 2, 3, 4, 5. Those are the indexes. That's how you're going to actually, that's how you guys are going to access those elements. So if I wanted to access element 10, I would have done S square brackets, did I say 10 or 20? Well, if it was 20, it would be 1. But there are different ways to actually do this, actually, that when we're going to talk about accessing elements in pandas, there's actually a better way to do it, okay? And I'm going to tell you how to do that in just a second. It's going to be it'll come in a couple minutes. We'll see. You notice that the data types are right next to it. So each index has its own data type. Now, that might not always be the case. I'm going to tell you that right now. It could also be a null value or an NaN value, not a number. because, we might not have assigned a number for that index. So keep in mind that our series won't be that beautiful. It could be filled with not number values, or it could be filled with just no values, okay? And then you have the type. These panda series all have these elements all have the same type, which is an integer. Okay. So what are the key features of a panda series? Okay. Indexing. Series can be indexed by labels or integer position. So I mentioned how we did it with the default integers. So if I said I wanted to access position 3, I could do that using, well, position 3 would have been element 4. My point is, though, is that we can index in 2 ways, almost like a dictionary. But dictionaries were a little bit more different in the sense that they weren't really ordered. And so you would access it using the key value, the key that you use for that specific value. This has both, okay? I also want you to keep in mind, actually, I'll keep that tip in just for a second. I'm going to move that when we talk about data frames, because it's going to be more important when we talk about data frames. Operations, series support vectorized operations, so you can combine different series together, like addition and subtraction. And then the series have many built-in methods that you can use for data manipulation analysis. Okay, so here's the code. I created a panda series using the same values as previously, but here's the difference that I did. I didn't just leave the default indexes. What I did was, in this case, I changed the indexes to, rather than 1, 2, 3, 4, 5, it's now A, B, C, D, E. And A, B, C, D, E are going to be used to actually access it. So let's actually access the elements. So I have to say, hey, let me print element 3, okay, the third element. And so the third element can be indexed in 2 ways. So the third element can be accessed with, look.
Yeah.
You're in the right class, right?
Yeah.
Awesome. I don't know. You might have to open up the Zoom if you want to see the presentation, because I can't really get it up to, okay? It's the office hours then. Okay, so series has a bunch of built-in methods that we can use for data manipulation analysis. We have the series there with not the default indexes, but you still can use the default indexes. So in the case of, I don't know if you guys can see my cursor, but if you look at the second column on, if you look at the second column where it says print SC and print S3, when we say print SC, it's going to print 30 because we input the index for 30 as C. Now, in the case of position 3, we have the default index there as well, but it's not listed here. So we would kind of have to guesstimate it here. So 0, 1, 2, 3. And so it would print out 40, which makes sense. It prints out 30 first because that's the one at position C, and then prints out 40 next because that's what it's at position 3. Okay. You can also perform vectorized operations, and it's very simple. It's not that big of a deal. So if you have the panda series name, we named it and assigned it to the variable name S. I put it as, okay, let's say S is equal to S plus 5. So S equals to S plus 5 means that I'm going to take all the elements in the series that we have. We assume that it's an integer, and we're just going to add 5 to each element. And that's what happens when we print out S. It performs this vectorized operation 15, 25, 35, 45, and 55. And so those have been added as well. And now you guys have probably recognized this little function over here, s.mean. You guys may have used the mean function for NumPy on the exam, but it comes back here in pandas as well. So print s.mean, print s.mean. Yeah. So yeah, s.mean. And it will compute that for you, 35. All right. So there's also attributes for the pandas series. So there's values, there's index, there's D type, and there's index of the D type. Okay, so values just returns the NumPy array of the series data. The index just returns a pandas index object of the series index. D type returns the data type of the series values. And index to D type returns the data type of the series index for labels. I just read that out directly from the slide. You guys can test that out for yourselves. Okay. But here's a practical or summary of how it would actually come. So in the case of this series there, we have 10, 20, 30, 40, 50, and then we assign these different indexes to actually do that. Here's me actually accessing the series attributes. So we have the name of the we have the name of the series and we have the values. Okay, and so when we access this attribute, we get all the values of the series, which are 10, 20, 30, 40, 50. It's not the index, right? Notice how we didn't get the index this time. When we printed out the series altogether, it printed out everything. Print out the indexes, it printed out the values, and it printed out the type. Maybe we don't want that, of course. So we want to just access the data. And so the data that we have will be stored in values. And so notice here, it's just one line, a list, 10, 20, 30, 40, 50, okay? And then when you do index, you get the indexes. So notice here that we don't get the elements. 10, 20, 30, 40, 50 do not show up when we ask to print out the index. It's going to say index A, B, C, D, E. And what is the index type? Well, the index type for this case is an object, okay? String object. Okay, now we can check the series dot values of the D type, data type. I'm going to say data type because I can't say D type like that. So when we ask for the type of the data, actually no, type, data type of the values of the data. What is the values of these data? So 10, 20, 30, 40, 50. What are these types of values? They're an integer. And so when we access this attribute, we get integer 64. And then when we do the same on just the indexes, right? Sir.index.data type, we get that the object is a data, that the indexes are an object data type. Okay. Now, I do want to keep in mind, and I do stress this a little bit, when you do use attributes, notice something that's different from methods. Methods, they would have the parentheses. They may or may not have arguments, but in every case, they have parentheses after the method name. In the case of attributes, these are attributes. These are not functions. So you're accessing, characteristics of the series. In this case, the characteristics will be values, the index, the data type of the values, and the data type of the index. So you don't really need, in fact, you wouldn't need to put the parentheses there. All right, so accessing elements. So when we access elements, we use the indexing operator with the square brackets, okay? And so when we were accessing elements prior, we were doing so with like we would do previously, in the sense that, like, how we access dictionary elements, how we access list elements, and how we access tuple elements, we use those square brackets with the numerical value of the index. So here, for example, we have a panda series, same panda series that I've been using with the previous slides. And I wanted to print out the first element. Well, the first element has an index of A. That's the index that we assign to it right here, right? So 10, 20, 30, 40 will have A, B, C, D, E, respectively, as their indexes, okay? And so when I print out index A of this panda series and I access it, remember, by doing S square brackets and then with A, and A is a character. That's how we specified it within the index. It'll be 10. So it prints out 10. Okay. Now, when we access elements, we can access multiple elements as well. And so how do we do that? Well, I ask it to print S, and then in square brackets, and then in another square bracket, I put the list of the values. I put A, C, and E. And so when we tell it to execute that, remember that this is double square brackets, it will print out ACE, ACE, 10, 30, 50. It will print out the indexes of those values of that at those indexes. And you can also do it via their original or default indexes, which were numerical values. And so if I want to print out the values from indices 2 to 2, indices 0 and 2, actually, no, in this case, I didn't print out 0 to 2. I printed out 0 and 2. But if you wanted to print 2, you would need 0 to 2. You would have used the colon. But in this case, we printed out 0 and 2 using the numerical indexes, the default indexes. And so it prints that out, 10 and 30. But when it does print it out, it still keeps the index that we assigned to it, because 0 and 2 are the default ones, but AC are the ones that you would actually use. Okay, so there's also the way of using lock, and you can also see ilock. Okay, ilook or lock. I don't know how to pronounce it. I never really pronounced it out loud like this. But my point is that this is one way to. This is another way to access elements, and you're going to see another way that's going to be extremely similar, but they differ very slightly. Okay, so in here you see that we have a panda series again, same one. And so rather than using S and then square brackets A, we're doing s dot log a. And so this accesses the number or the value at position A. Now we do the same thing as we did previously. We would do the ACE values and it prints it out the same way. It prints out 10, 30, and 50. And you can print out 0 and 2, the stuff at 0 and 2. But what do you guys notice here? What do you guys notice the difference there? So if you look here, when we wanted to print out the elements at indices 0 and 2, we used 0 and 2. We just plugged that in. But here, we're still using ASC. This is a key difference, by the way, that we're going to be seeing with lock and ilock. Okay, so keep that in mind. I'll let you guys, ponder this, and then we'll look at it a little bit in just a second. Okay, so now we have using the ilock attribute. I don't think it's an attribute, but whatever. Actually, yeah, it is an attribute. So now we look at the ilock one. The only difference is that it has the character I before it. So I comes before lock. And so when we use that on the same panda series, what do you guys notice? It prints out the exact same thing, but we use a different value within the square brackets. Here, the difference is that we're using all numerical values. So if we wanted to print out the first element, we're not using A anymore. We're using 0. If we want to print out the values at ACE, we're not using ACE anymore. We're using 0, 2, and 4. And if we want to print the values from 1 to 3, we're not, doing, A, B, C. We're doing a 1:4. So what's the difference between these two? You're going to be using both of these, but why do we need to know both of these for accessing elements? So ilock and lock are attributes in pandas, and they're used to access data from a data frame or series. So ilock and lock differ in the fact that ilock, or the one with the I in it, is used to access data by the integer location of the rows and columns. So that's what you probably noticed. We're only really using integers there. Now, when we use lock, we're using that, we're using the data or the labels that we had previously as the rows and columns, okay? And it allows us to select rows and columns using the labels and slicing operations, okay? So that's the case with both of them, but lock specifically is going to be using the labels for the rows and columns. ilock is going to be using the integer location for the rows and columns. Okay, let me give you another example to further illustrate the point. So let's say if we import, let's say that we have the panda series, a different panda series this time, where we have A 1, 2, 3, B 4, 5, 6, and C 7, 8, 9. Okay. Now this might be a little bit hard to dissect the first time. All right. So you're probably wondering, like, what the heck is this printing? So it'll make sense in just a second when you visualize what is actually being printed out. So this isn't like your stereotypical two-dimensional array. The way that it's done is you have to assume that it's each of these values represent a column, okay? And so let's do that. All right, hopefully I do this correctly. Okay, so it'll be A, it'll be B, it'll be C, and it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so hopefully you guys can see that. These are the labels, and then this is the data. Okay, and so we assign a default index here. So each of the columns have been named, but we don't have a name for the rows. And so for the name of the rows, we're going to do 0, 1, 2. Okay, so I'm going to separate this from the data. Okay, so our data actually is 1, 2, 3, 4, 5, 6, 7, 8, 9. But we also have indexes such as 0, 1, 2 that we shouldn't confuse with the actual data. And on top of that, we have ABC, which isn't data, but it's an index for the columns. Okay. Now let's dissect what's actually going on here. So we're using numerical values. So in the case of the first ilock, it says here 0 and then comma 1. And so what you're doing here is accessing the element, since you can only use columns here. Sorry, you can only use numerical values here. It's accessing the element that's at row 0 and column 1. Okay, so let's look at row 0. Row 0 is over here. I don't know if you guys can see that, but row 0 is here. Okay. That's row 0. And so we're going to be looking in the vicinity of this area. And then we're going to look at column 1. Well, A is not column 1. A is actually column 0. We can actually assume that A is 1 B is, sorry, 0, A is 0, B is 1, and C is 2. And so B would actually be column 1. And so when we do that, we look at row 0 and we look at column 1, our element or the thing that we will print out by accessing using the iloc function, iloc attribute would be 4. Okay, so that's how we would get 4. Now let's look at the next one. So now we're using it to access different first rows and columns. So in the case of here, it says select the first 2 rows and the first 2 columns, and we do so using the colon. And let me actually erase what I've done here. Okay, so I want you to keep in mind that the way that it's printed doesn't really look that great, but we'll look at what we have. Now, what I'm saying here, what I do mean by that is that if you look at A and B, shift it like 1 space or 1 tab. So A would be on top of 1 and B would be on top of 4. Hopefully me saying that will make it a little bit more easier of what's going on. And so we have this full pandas data frame, okay? We have this full pandas data frame, and we'll talk about data frames in just a second. But I'm sure most of you guys know what a pandas data frame is by now. Assume that we have this is the pandas data frame. And so now when we're using df.iloc, we're doing it like this. So df.iloc, and then we have 2, and then 2. Okay, so the colon emphasizes that we're going from the start all the way to position 2. Okay, and position 2 is it's not including position 2. Okay, and in the case of the second one, the column, it's going to be taking the columns until position 2, from start to position 2. Now, it doesn't include position 2. So if you look in the case of this data frame, we're doing from 0 to 2 basically. So it'll include 0 and 1, but remember that 2 is not included itself. So it'll print out 0 to 1. But does it print out what 7 and 8? We know that it prints out, well, we know that's going to print out elements in these first 2 rows. So we know it's going to be 1, 4, 7, 2, 5, or 8. It's not going to be all of them, but we know that the correct answer is in there. Now we have to look at the what the next one is. The column says colon 2. So colon 2 just simply means from the start to position 2 or column 2. And so it's not including column 2. And so we've already eliminated this. So I want you guys to just ignore the third row or the position 2 row. And then we're just going to look at the remaining value. And it tells us that we're looking at column 0 and column 1. We're going to stop at column 2 and we're not going to include column 2. And so we can just erase that as well. We're not going to include column 2. And now the answer becomes a lot more clear. We have 0 and 1, we have A and B. And so the data from that iloc, what we're accessing is 1, 4, and 2, and 5. And that's what it prints out, right? And it also prints out the indexes as well. If you notice here, it just doesn't print it out like, correctly. So like the reason why I'm using like a really weird compiler, I'm using like an online compiler just to get some type of output. My point is though, if you look at that 1 there in the third column and the third row, the A should be on top of that. And if you look at the number 4, B should be on top of that. And so that is their answer. 0 and 1 are our rows that we access. A and B are the columns that we access. And so we only are going to keep values that we wanted to access in those rows and columns that satisfy both of those conditions. And so since these values satisfy both conditions in the sense that we want values in the first 2 columns and the first 2 rows, it'll print out 1, 4, and 2, and 5. Okay. And then the last one is simply just accesses the last row and the last column. So what element is in the last row and the last column? Well, I kind of erased it, but it's going to be in the last row and the last column. It's going to be in the most corner element. And in this case, it is 9. All right, so now we're going to do lock example. Now the difference here is that we're going to be using a letter. We're not going to be using numerical values. All right, so let's say if we wanted to select an element at row A, column B, we can just do A and then comma capital B. It's as simple as that. Now, if we wanted to get multiple rows, what we do is we use the square brackets, and then we use more square brackets. So we create a list of the indexes that we want for rows, and we want an list of the indexes that we want in columns. So you notice here that in df.lock, in the second print statement, we have one big square bracket, which is gonna, encompass most of what we want. But then we have a split. So we have one list and we have two lists. The first list is gonna be the number of rows that we want, and the second list is the number of columns that we want. Or I shouldn't be saying number, but rather which columns and which rows that we want. So A and B, lowercase, are the rows that we want. Capital A and capital B are the columns that we want. And let's say if I wanted to select all rows, but the ones in column C, what we can do is, for the case of rows, we could just put a colon. This will imply all the rows. And then when we put comma, it's going to know, hey, we want now a column. And so if we wanted to do all columns, we would have put the colon, but we don't. We just want the ones in column C. And so we put in capitalized C. And so it prints out the values in column C. And it still keeps the values. Since we said that we wanted to keep all the rows, it has the name of the rows there. So A, B, C. They were, there were only 3 rows and we kept all of them. And when we printed it out, all of them are still there. It's just the ones that are only in column C. All right, so how much time do we have? We have around 16 minutes. Okay, so let's see how much we can get done. 16 minutes, okay? So I'm going to make it a little bit more quicker so that we can get all this stuff. Here's an example of adding series together. And so I have 2 series. I created one with a dictionary. So I created 2 series, and one of them has Rutgers, Princeton, and MIT. And it's created via a dictionary. And then I put that in series 3, okay? And in series 4, I put the same values as well. But I keep the indexes as other universities. So I have a very weird difference here. I have dictionaries that already have indexes, and then I have indexes that may or may not have the same universities. And so what happens when I add these 2 series together? Well, the original series, series 3, will have Rutgers, Princeton, and MIT as their respective indexes, and then it'll have the values, those values for each of them, respectively. Using respectively, I don't know why I used that, but anyway, and now in the series 4 one, we have the same values, but we have the same things, but now we have different indexes, and so this might actually change. So this is what the program does. So in the case of adding series together, when you're combining them together, how do I explain it? So if an index is in series 3 and series 4, it'll be added together, okay? So if it exists in series 3, if it exists in the first series and the second series, so if you're adding 2 series together, if it exists in the first series and the second series, their numbers will add together, their indexes, assuming that they can be even added together, okay? Now, in the case that an index exists only in one of the series, like UPenn or MIT, then it gets a little bit finicky. It doesn't know what to do. And so it just doesn't store value in that case, okay? So MIT is in series 3, but it isn't in series 4 because we didn't keep it as an index in series 4, okay? So those are the, this is what happens when we add series together. The ones that are in both of these series, they get added, and if they're not in both of the series, they don't really have a value. They have a null value or an NaN number. Okay, so let's look at the first practice problem. Very simple problem. You have 2 panda series as follows. What will be the output of that? Okay, so you have 10, 20, 30. You have 5, 10, 15. They have A, B, C, D. They have B, C, D. What do you guys notice? Well, we notice 2 things. We notice that A is in series 1, but it's not in series 2. Actually, we notice 3 things. We also notice that D is in series 2, but it's not in series 1. And the third thing we notice is that BC is in both series. So B and C are in series 1 and series 2. So what we know from the previous problem is that B and C will have a value. It'll be 20 and 30 in series 1, and it'll be 5 and 10 in series 2. And so those numbers will get added together, 20 plus 5 and 30 plus 10. But what about the values of 10 and 15? Which correspond to the indexes A and D. In those cases, they won't store a value, okay? And that's what happens. What's 20 plus 5? It's 25. What's 30 plus 10? It's 40. B gets added to B, C gets added to C. D has nothing to add, so it's like, hell no, I got nothing, so NaN. A has nothing to add as well. It's like, hell no, so we'll keep it at NaN. Okay. So now let's get into what a pandas data frame actually is. Okay, so a pandas data frame is a two-dimensional table-like data structure consisting of rows and columns. What I was doing on the blackboard is an example of a pandas data frame. It isn't one-dimensional. It has rows and columns, and you can represent it almost like a CSV Excel sheet. Okay, and I give the analogy there. It's similar to a spreadsheet or SQL table. Now, in each column in a data frame, it represents a variable, with each row representing an observation. Okay, what does that mean? So data frames have, when we think of an Excel sheet of many different people, we think of the rows as each as a separate person, and then each column as a characteristic of that person. For example, when we grade papers, we'll put them not as columns. We won't put every individual student as columns. We'll often put them as rows. So you can go up and down and see which students are there. It's very simple. It's something that we do normally. And then when we look on the sides, we're like, okay, this is their assignment 1 grade, this is their assignment 2 grade, this is their homework, this is their participation, and then this is their extra credit, and this is their exam grade. Okay. So that's what I mean by each row representing a observation. Each row is someone different or something else that you're observing. And every column is a variable of that observation. Now, of course, technically speaking, they could be reversed. But you'll find out very, if you do try to take that way, you'll find out it'll be against like your intuition. And on top of that, like pandas is like the way that pandas is built, it's like it makes it a little bit more easier to make each row the observation. But if you want to try that as a challenge just to see how it works, be my guest, but you will be disappointed. Okay, so you can create data frames in a variety of different ways. And here are the 3 examples. So we have a dictionary of lists or arrays, and each key represents a column name and each value represents the data. So in the case of the data frame here, we use pd.dataframe. So we're using the pandas library, and then we're doing a data frame. And we use just one dictionary, and we're like, okay, we have the name and we have the age. Okay, so we have the name as the indexes and we have the age as the other one. And then we also have salary as well. Now we can also do a list of dictionaries. What does a list of dictionary mean? Well, a list of dictionaries simply just means that we have name, age, and salary in this case, all in one dictionary. And then we do the same for every single one. So previously we had name, age, and salary, all of them in the same order. And on top of that, all together. So name, age, and salary, these are all characteristics. And so we have all the characteristics together. We don't have them separated by which is which. In the case of the second one, where we have each dictionary represents a row of data, each dictionary we have in this case is an observation. So each dictionary is a different person. It's a different row. And this is the one that you're going to use a lot of. It's going to be reading from a CSV file. And so reading from a CSV file will be data.csv. Once a data frame is created, it can be manipulated in many ways, and you'll do pre-processing, manipulation, and analysis on it. Finally got it. Okay. So here, we're going to do this in 2 different ways. It says here, create a data frame using a dictionary of lists that contain the following data. Okay. And so this would be the solution to that. Notice here, we have the names as its own dictionary. We have name as a list. We have ages as a list, and we have salaries as a list. And each of these are paired up with a key, which would be the name of each of these columns. Okay. So in this solution, we have it set so that every thing that we have here is differentiated by the column. And so when we print it out, we should get basically this. Now, let's do it with a list of dictionaries. And so what the difference is here is that rather than doing it by name, age, and salary, we're going to be doing it by Alice, Bob, and Charlie. And that's what we do. We do a name, Alice, age 25, salary 50,000. Alice is done. Now let's do the next person. Let's do Bob. Bob has a name Bob. His age is 30 and his salary is 60,000. Awesome. Bob is now done. We're not doing Alice, Bob, and Charlie first, and then we're not doing 25, 30, 35 as ages second. We're doing it by observation. And we print it out, we still get the same thing. The data frames have different methods that you can use, and so we're going to just go through every single one of them. Okay, so hopefully this should be extremely quick and should be relatively intuitive. All right, so index just simply returns the indexes of the data frame. And so let's say if we have this data frame here and we ask it to print out the index, the indexes in this case are going to be 0, 1, 2, and 3 because we're using the default indexes for what? Each iteration. We do have column names, so we do still have column names, which is pretty cool, but we don't have the regular indexes for each of the rows. And so even though you technically speaking, you can use the name as the row as well. My point is that when you do print out, you would get the start is 0, the stop is 3, and step is equal to 1. That simply means what? There's 3 elements, 1, 2, and 3, and it stops at 3, and it goes by 1. Okay. 3 is not included, of course. So if you access something at position 3, it doesn't exist. But you have something at position 2, and that's the third element. All right, so in columns, that has the values of the things that we had. So previously, the indexes were the rows, but this one has the columns. So df.columns returns the column labels. Same type of data frame. And in this case, it'll return the indexes, name, age, and salary. Notice how we don't have the start, stop, and end thing. In this case, it's an object. And so it will say that the data type is an object for indexes. It's not numerical. If you want to just print out the values and none of that indexes, A, B, C, 0, 1, 2, 3 type things, we can just print out the values. And in that case, it'll be Alice, it'll print it out basically in a list. So each list is going to represent a different observation. So Alice 25, 50,000 is an observation. Alice is a 25-year-old person that makes $50,000. Charlie is a 35-year-old person that makes $70,000. I doubt you're going to really be using it, but it's nice to have in your toolkit. If you want to transpose it, transpose just simply means, just alter it, switch the rows with the columns with the rows. You can do that with df.T. All right. Nothing too out of the ordinary. And we did this in NumPy as well, so it shouldn't be too difficult. All right. df.shape. Shape just returns a tuple that represents the dimensions of the data frame. And so we'll use the example that we had previously, Alice, Bob, and Charlie. Age 25, 30, 35, salary 50,000, 60,000, 70,000. What do we have? We have 3 rows, we have 3 columns, and so the dimensions are 3 by 3. All right. df.head just simply returns the first n rows of the data frame, where n is 5 by default. You can put the argument n in there, and you can get the first n rows. But if you don't put any arguments there, it'll just do the top 5 by result. And in this case, since we only have 3 rows, it's only going to print out the first 3 rows, which coincidentally are also the last 3 rows as well. df.tail, same situation, just backwards. Rather than printing out the first n values, you print out the last n rows. Did I say values? My bad. It print out the last n rows. And so it's n by 5 by default, so it'll print out the last 5 rows by default. Okay. Let's do a couple more practice problems to call it a day. Okay, hopefully, got a couple slides left. Can we do it in 2 minutes? What does this code execute? Well, we have np.arrange. If you guys recall what np.arrange does, it'll basically print out 0. Wait, in this case, what is it? It's 1 to 5. So the values will be 1, 2, 3, and 4. It's going to create a list of values and NumPy array of 1, 2, 3, and 4. Okay, 5 is not included because 5 is the value that we use to end it. Okay, and so this is what's going to print out. Don't get it confused with 0, 1, 2, 3. 0, 1, 2, 3 are the indexes for those values. These are the actual data points. 1, 2, 3, 4 is the actual values of the Panda series. 0, 1, 2, 3 is the indexes that you use. And you have the data type as well, which is integers. All right. In this case here, what's going on? So we're creating a NumPy list or a NumPy array, and it's going to have values till 9. So I'm assuming 0, 1, 2, 3, 4, 5, 6, 7, 8. And then we reshape it so it's two-dimensional, and it's going to be 3 by 3. And then we give it the indexes ACD and columns Ohio, Texas, and California. And so when we print out column A, what do we get? Let's put that here. So when we print out column A, we're going to be getting out 0, 1, 2. Okay. So let me do it like this actually, so that's a little bit more simpler. Okay, so it'll be actually I don't think I need to explain it on the whiteboard. What I'm saying here is that A is going to be the columns are Ohio, Texas, and California. And so when we access the elements at A, it'll be 0, 1, 2. But in the case of one column, a row 1, it'll be 3, 4, 5. Okay, so column 1 would be 3, 4, 5. Column A would be 0, 1, 2. Why do I keep saying column? I mean row, my bad. So row A would be 0, 1, 2. Row 1 would be 3, 4, 5. You can also drop elements. And so I give you the basic syntax to drop elements. You have labels, you have the axis, you have the index, you have the columns, you have the level, and you have the in place and error. You don't have to worry about the last like 3 or 4, but you're gonna probably have to know like axis, index, and columns and labels. So labels, the index or columns, labels to drop. Axis is which rows you want, 0 or if you want to drop rows or if you want to drop columns. So 0 is rows, columns is 1. Indexes are the index labels that you want to drop. Columns are the column labels that you want to drop. Okay. And then you don't have to worry too much about level, in place, and errors. But if you are using in your projects, it's something handy that I need to use. Okay. So here's an example where I have these data points here. We have name, age, and city. And so when I ask it to drop basically the column city, it will have name and age, but it won't have, and by the way, name goes on top of John and age goes on top of 25. It'll no longer have city. So we remove city from the data frame and that's been dropped, okay? And we use the arguments columns is equal to city. So that's what we're dropping. And so that's has been dropped when we print it out. All right, so this is the last problem before we call it a day. Remove rows with missing values, import pandas as PD, and import NumPy as well, because why not? Okay, and so we have these np.nan values, but how do we get rid of them? Remove rows with the missing values. np.nan is a missing value. When we print it out, it would be NaN, but when I copied and pasted it, I'm assuming it came out as np.nan. Now you could make an algorithm and everything like that, but there is a pretty handy dandy function that you can use, and it's called drop NA. And so when you do df.drop NA, it'll drop all the NaN values. And so when you print it out, it no longer has those NaN values. Okay. And that wraps up recitation. Let me know if you guys have any questions, but you guys are now free to go. I'll post the recording when I get the chance to.